Imagine stepping outside during the worst storm in recorded history. The wind is screaming through the air. Trees bend until they seem moments away from snapping. Roof tiles tear free and vanish into the darkness. Every instinct tells you to find shelter immediately. The atmosphere itself feels alive, angry, almost conscious. Most people would consider such a storm unimaginable. Yet even the strongest hurricanes ever recorded on Earth would seem surprisingly weak when compared to what exists elsewhere in our solar system. Far beyond the orbit of Mars, beyond the asteroid belt, and hundreds of millions of miles from the warmth of Earth, there hangs a giant world wrapped in clouds. At first glance, it appears peaceful. Through a telescope, Jupiter looks elegant, almost artistic. Cream-colored bands stretch across its enormous globe. Swirls of gold, orange, and white blend together like brush strokes painted by some cosmic hand. But appearances can be deceptive. Beneath those beautiful clouds lies one of the most violent weather systems humanity has ever discovered. A storm so large that our entire planet could disappear inside it. A storm that has been raging for centuries. A storm that, according to everything we know about weather, should not exist at all. This is the story of Jupiter's great red spot. To understand why this storm is so extraordinary, we first need to understand the world that created it. Jupiter is not simply another planet, it is the largest world in the solar system. More than 1,300 Earths could fit inside its volume. If Earth were the size of a grape, Jupiter would be closer to the size of a basketball. Everything about it operates on a scale that challenges human intuition. Yet despite its immense size, Jupiter remains surprisingly mysterious. Unlike Earth, it has no true surface. There are no mountains, no oceans, no continents, no place where you could stand and look at the horizon. Descending through Jupiter is not like landing on a planet. It is more like falling into an endless atmosphere. At the uppermost levels, the clouds appear relatively calm. They drift through an environment dominated by hydrogen and helium, the same elements that make up most of the sun. But as you descend deeper, the pressure begins increasing rapidly. The atmosphere becomes denser. Temperatures climb. Eventually, the distinction between gas and liquid starts to blur. The deeper you travel, the stranger everything becomes. Hydrogen, the simplest element in the universe, begins behaving in ways almost impossible to imagine. Under crushing pressures, it transforms into exotic states of matter. Layers of liquid hydrogen may stretch across vast regions beneath the clouds. Even deeper, scientists suspect there may be a massive core hidden beneath thousands of miles of atmosphere. But despite decades of observation and multiple spacecraft missions, nobody knows exactly what that core looks like. Some models suggest a dense rocky structure many times the mass of Earth. Others suggest something less solid, perhaps a partially dissolved core mixed into surrounding layers. Jupiter guards its secrets well, and among all those secrets, none has captured humanity's imagination quite like the Great Red Spot. The storm dominates Jupiter's southern hemisphere, like a giant eye staring into space. It is immediately recognizable in photographs. Even people who know little about astronomy often recognize the famous crimson oval. Yet most photographs fail to communicate its true scale. The Great Red Spot is not merely large, it is absurdly large. Even after centuries of gradual shrinking, it remains roughly 1.5 times wider than Earth. Entire continents could fit comfortably within its boundaries. If somehow transported to our planet, it would stretch across oceans and swallow nations. And unlike hurricanes on Earth, this storm never seems to end. Our strongest storms draw energy from warm oceans. Eventually, they weaken. They make landfall. They lose access to their fuel source. Friction slows them down. Mountains disrupt their structure. Continents tear them apart. Jupiter offers no such obstacles. There is no land. There are no mountains. There is no coastline waiting to absorb the storm's energy. The great red spot spins freely through an endless atmosphere. That alone may explain part of its incredible longevity. Astronomers have been observing it for centuries. Historical records suggest that a similar feature may have been visible as far back as the 17th century. If those observations refer to the same storm, then the Great Red Spot has survived longer than entire nations. It has outlived generations of scientists. It was already raging long before modern astronomy existed, and still it continues. When NASA's Juno spacecraft arrived at Jupiter, scientists finally gained an opportunity to investigate the storm more closely than ever before. Previous observations could only reveal what was happening near the cloud tops. Juno allowed researchers to probe deeper. What they discovered was astonishing. The Great Red Spot does not merely skim the upper atmosphere. It extends far below the visible clouds. Measurements suggest that its roots plunge hundreds of miles downward. That is dozens of times deeper than Earth's oceans. Imagine a hurricane whose foundations reach deeper than entire planetary ecosystems. Yet even those measurements may not tell the full story. Some researchers suspect the storm could extend farther still. And perhaps even more mysterious is what happens above it. Jupiter's upper atmosphere is brutally cold. Temperatures can plunge to around negative 234 degrees Fahrenheit. Yet directly above the Great Red Spot, scientists detected something completely unexpected: extreme heat. Temperatures reaching around 2,400 degrees Fahrenheit, hotter than molten lava, hotter than many industrial furnaces. For years, researchers struggled to explain how such intense heat could exist in a region surrounded by freezing atmospheric conditions. The leading explanation involves waves, not ocean waves, atmospheric waves. As the Great Red Spot churns through Jupiter's atmosphere, it may generate enormous gravitational and sound waves. These waves travel upward through the atmosphere before releasing their energy at higher altitudes. That released energy heats the surrounding gas. In other words, the storm may be creating its own atmospheric furnace, a weather system powerful enough to alter temperatures thousands of miles above itself. The deeper scientists investigate, the stranger the story becomes. And yet, despite everything we have learned, the Great Red Spot remains one of the solar system's greatest mysteries. Nobody fully understands what fuels it. Nobody fully understands why it survives. Nobody fully understands why it became red in the first place. Some theories suggest ultraviolet radiation from the sun interacts with chemicals in Jupiter's atmosphere. Others point toward compounds rising from deeper layers. Certain gases may undergo chemical transformations when exposed to radiation, producing the famous crimson color. But no explanation has yet solved the mystery completely. Perhaps most surprising of all is that the storm may be changing. For decades, astronomers believed the Great Red Spot was slowly dying. Observations showed it shrinking over time. Yet newer measurements revealed something unexpected. Winds along its outer edge appear to be increasing in speed. The storm is becoming smaller, but in some ways more intense. It is as though the giant vortex is evolving before our eyes. Whether it will eventually disappear or survive for centuries more remains unknown. But one thing is certain: the Great Red Spot is not the only impossible storm in the solar system. because as we continue our journey beyond Jupiter, we will discover giant thunderstorms on Saturn, planet-wide dust storms on Mars, mysterious atmospheric structures on Venus, and weather systems unlike anything found on Earth. The universe, it turns out, is filled with storms, and we are only just beginning to understand them. The Great Red Spot often receives all the attention. It appears in textbooks, documentaries, posters, and spacecraft photographs. For many people, it has become the symbol of Jupiter itself. Yet, if you could somehow hover above the giant planet and watch its atmosphere for weeks or months, you would quickly realize something surprising. The Great Red Spot is not unusual on Jupiter, at least not in the way we might think. What makes it extraordinary is not that it exists. What makes it extraordinary is that it survived, because Jupiter is a world where storms are born constantly. Its atmosphere is not a quiet blanket of clouds drifting through space. It is an ocean of turbulence stretching thousands of miles deep. Powerful jet streams race around the planet. Hot gases rise from below, while cooler material sinks from above. Vast currents collide and twist together. Everywhere energy moves. Everywhere motion creates instability. And wherever instability exists, storms eventually follow. Seen from orbit, Jupiter resembles a living painting. Bands of cloud wrap around the planet in alternating directions. Some move eastward, others move westward. The boundaries between these bands become battlegrounds, where enormous vortices emerge. Many of them are larger than Earth. Most eventually disappear. A few survive for years. Some merge with one another. Others are consumed by larger storms. The atmosphere behaves less like weather and more like an ecosystem, a constantly evolving landscape of gigantic storms, feeding, growing, colliding, and vanishing. In some regions, smaller vortices orbit one another, like dancers performing a slow cosmic ballet. In others, entire chains of storms stretch across thousands of miles. Their shapes constantly change as they exchange energy with surrounding currents. If Earth
1 minute now to
experienced
touchdown.
weather on
Discovery's
Jupiter's
landing
scale,
gear will be locked down and into
forecasts
place
would
at
become
300
almost
feet in
meaningless.
altitude.
Imagine hurricanes larger than continents appearing and disappearing across the globe. Imagine storms
It's
lasting
currently
centuries.
3,500 feet.
Imagine atmospheric systems
and,
so deep they extend
traveling
farther
at a rate of
downward than Mount
370
Everest
miles per
rises
hour.
upward. That is everyday life on Jupiter. And yet, despite all
30
this
seconds
chaos,
until touchdown.
Jupiter is not the only world where nature has created impossible weather. Farther outward lies Saturn. From Earth, Saturn appears serene. Its magnificent rings create an image of elegance unmatched anywhere else in the solar system. If Jupiter looks powerful,
Main gear,
Saturn looks graceful.
landing
But
gear now
beneath
down
that
and locked.
graceful appearance lurks one of the strangest atmospheric mysteries ever discovered. At Saturn's North Pole exists a gigantic storm
Main gear
unlike
touchdown.
anything found
Pilot
elsewhere.
Jim Dutton now
It
deploying the
has
drag
6
chute.
sides, not approximately 6 sides, not vaguely hexagonal, a
Nose gear
remarkably
touchdown.
precise hexagon, thousands of miles across.
That brings an
perfectly
end to the
surrounding the North Pole.
STS-131 mission, the
Scientists
131st
first
Space Shuttle
noticed it
flights, and the
decades ago,
33rd to the
and ever
International
since,
Space Station.
it has remained one of the greatest mysteries in planetary science. Imagine flying above
Discovery
Earth
left Florida
and
on
discovering
April
that
5th
a
with
hurricane has
7.6
somehow
tons of new
organized
science
itself
equipment and spare
into a
parts,
giant
including
geometric shape,
equipment that should improve the
visible
station's
from space.
capability for Earth
It sounds
observation work,
impossible,
equipment that could help
yet
astronauts
Saturn's
avoid muscle
hexagon is
atrophy,
real.
and
Even
scientists
more
better understand
strangely,
muscle atrophy,
it
and
appears
equipment that
remarkably
will
stable.
help keep the station systems cooling
Hurricanes on
properly.
Earth drift across oceans and continents. They weaken and disappear. Saturn's hexagon remains anchored to the pole, rotating along with the atmosphere around it, year after year, decade after decade, as though the planet itself has carved a permanent shape into its weather. Researchers have attempted to recreate similar patterns in appears suddenly. At first, it looks relatively small. Then it begins growing, growing, and growing. Eventually, it stretches around much of the planet. The Great White Spot is essentially a colossal thunderstorm system. Lightning flashes continuously within towering cloud structures. At its peak, lightning can occur more than 10 times every second. Imagine standing beneath a thunderstorm where the sky never stops flashing. One strike, then another, relentlessly, for days and weeks. The energy involved is staggering, and yet scientists still debate exactly what powers it. Some believe sunlight provides the necessary energy. Others argue that heat escaping from Saturn's interior plays a more important role. The answer may involve both. Farther inward, another mystery awaits. Venus. If Saturn surprises us with geometry, Venus surprises us with contradiction. At first glance, Venus should resemble Earth. It is similar in size, similar in mass, similar in composition. Yet Venus became something entirely different. Its thick atmosphere traps heat with devastating efficiency. Surface temperatures climb high enough to melt lead. Clouds of sulfuric acid drift through the sky. Atmospheric pressure crushes everything beneath it. It is one of the most hostile environments in the solar system. And yet even here, weather creates astonishing structures. Near Venus's poles spin gigantic vortices. These atmospheric systems behave in ways scientists still struggle to understand. Even stranger, the atmosphere races around the planet dramatically faster than the planet itself rotates. Imagine standing on a world where the air circles the globe much faster than the surface beneath it. That is Venus, a planet where the atmosphere seems determined to ignore common sense. Then there is Mars. Unlike Jupiter, Saturn, and Venus, Mars possesses only a thin atmosphere. At first glance, it seems unlikely that such a world could generate significant weather. But appearances are deceptive. Mars hosts storms, capable of swallowing the entire planet. The process begins simply enough. Dust rises into the atmosphere. That dust absorbs sunlight. The atmosphere warms. Warmer air strengthens winds. Stronger winds lift more dust. And so the cycle continues. Eventually, local storms merge into regional storms. Regional storms merge into global storms. The entire planet disappears beneath a veil of dust. From space, Mars can transform into a nearly featureless sphere wrapped in reddish haze. Mountains vanish. Valleys disappear. Even giant volcanoes become hidden beneath the storm. For weeks or months, the planet effectively becomes weather. One gigantic atmospheric event, visible across millions of miles of space. The more scientists explore these worlds, the more they realize that weather is not merely a local phenomenon. It is universal. Wherever atmospheres exist, nature begins experimenting. Different temperatures, different pressures, different chemical compositions, different gravitational environments. Each combination produces something unique. A giant red vortex, a six-sided hurricane, a planet-wide dust storm, an atmosphere that outruns its own world. And yet, as strange as all these storms may seem, they pale in comparison to what lies farther ahead. Because beyond questions of weather lies a deeper mystery, a question not about storms themselves, but about planets, how they form, how they change, and how entire worlds can lose everything they once had. Because our next destination is Mars, and hidden within its frozen deserts is evidence that the red planet was once something completely different. A world of rivers, a world of lakes, perhaps even a world capable of supporting life. Today, Mars feels quiet, not peaceful, not calm, quiet. There is a difference. A peaceful place feels alive. A quiet place feels empty. When spacecraft send back images of the Martian landscape, we see endless deserts stretching toward distant horizons. We see rust-colored plains covered in dust. We see frozen polar caps and extinct volcanoes towering over a world that seems frozen in time. Nothing appears to move. Nothing appears to grow. Nothing appears to live. At first glance, Mars looks like a dead planet. Yet the deeper scientists explore the red planet, the stranger the story becomes. Because everywhere they look, they find evidence that Mars was once completely different. Billions of years ago, Mars may have resembled Earth far more than the frozen desert we know today. Rivers flowed across its surface. Lakes filled enormous basins. Floodwaters carved valleys thousands of miles long. Perhaps even oceans covered significant portions of the northern hemisphere. The evidence is everywhere. Ancient river channels snake across the landscape. Dry lake beds remain frozen in place. Delta formations reveal where flowing water once deposited sediments over immense periods of time. Some valleys appear so familiar that they could almost belong on Earth. Yet, there is one enormous difference. On Earth, the rivers are still flowing. On Mars, they vanished billions of years ago. The mystery is not whether water once existed there. The mystery is where it went. To answer that question, scientists had to travel back through the planet's history. Ancient Mars was warmer. It possessed a thicker atmosphere. That atmosphere trapped heat, allowing liquid water to remain stable on the surface. Rain may have fallen from clouds. Snow may have accumulated in mountain regions. Seasonal weather may have shaped the planet for hundreds of millions of years. For a brief moment in cosmic history, Mars may have been habitable. Then something changed. Unlike Earth, Mars is relatively small. A smaller planet loses internal heat more quickly. Over time, its molten interior began cooling. As that happened, something critically important started weakening: its magnetic field. Today, Earth possesses a powerful magnetic shield, generated by movements deep within its molten core. This invisible force field protects our atmosphere from a constant stream of energetic particles flowing outward from the sun. This stream is known as the solar wind. The name sounds gentle. The reality is not. The solar wind is a relentless storm of charged particles racing through space at extraordinary speeds. Every second, the sun throws vast quantities of material into the solar system. Earth survives this bombardment because its magnetic field deflects most of those particles. Mars once had a similar defense. Then it disappeared. Without its magnetic shield, Mars became exposed. Imagine removing the roof from a house during a hurricane. Now imagine that hurricane lasting hundreds of millions of years, particle by particle, molecule by molecule. The solar wind began stripping away the Martian atmosphere. The process was slow, far too slow for anyone to notice during a human lifetime. But over geological timescales, it was devastating. The atmosphere became thinner. The planet grew colder. Liquid water became increasingly difficult to sustain. Rivers froze. Lakes disappeared. The climate collapsed. Mars slowly transformed into the frozen world we see today. And yet traces of its former life remain everywhere. One of the most dramatic examples comes in the form of gigantic flood channels. Some regions of Mars bear evidence of catastrophes almost beyond imagination. Researchers believe that enormous quantities of water may have been released suddenly from underground reservoirs. These floods were unlike anything in human history. Entire landscapes were reshaped. Valleys hundreds of miles long formed in relatively short periods of time. Water surged across the surface with such force that it left scars visible from orbit billions of years later. Standing beside one of those ancient channels would be like standing next to the ruins of an extinct ocean. The scale is difficult to comprehend, and perhaps even more remarkable is the fact that Mars continues to experience weather today. The atmosphere may be thin, but it is not absent. Winds still sweep across the planet. Dust still rises into the sky. Storms still form. Some become so large they engulf the entire world. Unlike Earth's hurricanes, Martian storms consist primarily of dust. Tiny particles absorb sunlight and warm the surrounding air. That warming strengthens winds. Stronger winds lift more dust. More dust absorbs more sunlight. A feedback loop emerges. The storm feeds itself. What begins as a local disturbance can eventually spread across continents, then hemispheres, then the entire planet. For months, Mars can disappear beneath a blanket of airborne dust. The sky darkens. Visibility collapses. The landscape vanishes. Robotic explorers on the surface must simply endure. One famous example occurred in 2018 when a global dust storm enveloped the planet and ultimately ended the mission of NASA's Opportunity rover. After years of exploration, the rover lost access to the sunlight needed to power its systems. The storm became part of Mars's history, another reminder that even a dying world remains active. Yet, perhaps the most intriguing discoveries lie beneath the surface. Scientists increasingly suspect that Mars may still contain significant amounts of frozen water underground. Vast glaciers hide beneath layers of dust and rock. Ancient ice sheets preserve records stretching back millions of years. These frozen deposits are more than geological curiosities. They are time capsules. Every layer contains information about past climates. Every deposit preserves clues about how Mars changed over time. And perhaps, just perhaps, they preserve something else. Life. The possibility sounds extraordinary, yet it refuses to disappear. Life on Earth emerged remarkably quickly once conditions became favorable. Within a relatively short period after our planet cooled, simple organisms appeared. If similar conditions once existed on Mars, why would life not emerge there too? Researchers have discovered that certain terrestrial microorganisms can survive astonishingly harsh environments. Some endure extreme cold. Others tolerate radiation levels that would kill most living things. A few can remain dormant for millions of years. Experiments simulating Martian conditions produced surprising results. Certain microbes survived far longer than expected. Not years, not centuries, millions of years. This raises an intriguing possibility. If life ever emerged on Mars, perhaps some remnants still exist underground, hidden beneath layers of rock, protected from radiation, waiting. No evidence has yet confirmed this idea, but the possibility remains. And that possibility has transformed Mars into one of the most important targets in the search for extraterrestrial life. Because finding even the simplest Martian microbe would change everything. It would mean life emerged independently, twice within the same solar system. And if life can appear twice here, perhaps it appears throughout the universe. But Mars is only one candidate, because farther outward, orbiting the giant planet Jupiter, lie worlds that may be even more promising. Frozen worlds hiding enormous oceans beneath thick shells of ice. Worlds where liquid water exists today. Worlds where life might still be thriving at this very moment. And among them, one moon stands above all others, a world called Europa. The deeper scientists looked into Jupiter, the more they realized that the giant planet was not the only wonder in its neighborhood. Surrounding Jupiter is an entire miniature solar system. Dozens of moons circle the gas giant. Some are tiny captured asteroids. Others are worlds in their own right. If they orbited the Sun directly instead of Jupiter, many would easily qualify as major planets in their own stories. And among all of them, one moon continues to capture the imagination of scientists more than any other: Europa. At first glance, Europa does not look particularly exciting. There are no towering volcanoes visible from orbit, no colorful storms swirling across its surface, no giant rings, no glowing atmosphere. Instead, Europa appears almost simple: a bright white sphere wrapped in ice. But simplicity can be deceptive, because hidden beneath that frozen shell may lie one of the most extraordinary environments in the entire solar system: an ocean, not a lake, not a collection of underground pools, an actual global ocean, a vast body of liquid water that completely surrounds the moon beneath its frozen crust. And if scientists are correct, that ocean contains more water than all of Earth's oceans combined. The idea sounds almost impossible. Europa is located more than 480 million miles from the Sun. At that distance, sunlight is weak and temperatures are brutally cold. Surface temperatures can plunge below negative 250 degrees Fahrenheit near the equator, and even lower near the poles. By all logic, Europa should be frozen solid. Yet it isn't. Somehow, beneath miles of ice, liquid water survives. The secret lies in Jupiter. Europa does not orbit a quiet planet. It orbits the largest object in the solar system after the Sun itself. Jupiter's gravity constantly pulls on Europa. As the moon moves along its slightly elliptical orbit, the strength of that pull changes continuously. Europa is stretched and squeezed over and over again. Imagine repeatedly bending a paperclip. At first, it seems insignificant, but eventually the metal begins warming. The same principle operates inside Europa. The moon flexes under Jupiter's gravitational influence. That flexing generates heat, not enough to melt the entire moon, but enough to keep an enormous ocean from freezing. In a strange way, Europa remains alive because Jupiter never lets it rest. The moon is constantly being kneaded by gravity, constantly heated, constantly changing. The first close-up images of Europa arrived in the 1970s. Scientists expected to see a heavily cratered world similar to many other moons. Instead, they found something unexpected. Europa's surface looked young, very young, compared to most worlds in the solar system. Impact craters were surprisingly rare. The landscape appeared smooth. Long fractures stretched across the surface like cracks in a gigantic frozen pond. Some of these fractures extend for thousands of miles. Others intersect and weave together into intricate networks. It looked less like a dead moon and more like a frozen shell floating atop something active beneath. The more researchers studied those fractures, the more convinced they became that Europa's crust was moving, breaking, reforming, shifting over time. Something underneath was influencing the ice, something powerful. Then came an even more exciting discovery. In 2012, astronomers detected enormous plumes of water vapor erupting from Europa's surface. The jets shot hundreds of miles into space. Suddenly, scientists realized they might not need to drill through miles of ice to study Europa's hidden ocean. The moon itself could be providing samples. Every eruption potentially launches material from the subsurface ocean into space: water, minerals, perhaps even organic molecules, maybe much more. For scientists searching for life beyond Earth, this was like finding a naturally open doorway. Instead of digging down into the ocean, Future spacecraft could simply fly through the plumes and analyze their contents. The implications were enormous, because where there is liquid water, scientists immediately begin asking a familiar question. Could there be life? On Earth, life seems almost obsessed with water. Every ecosystem depends on it. Every known organism requires it. Wherever liquid water exists on our planet, life finds a way. The deepest oceans, frozen Antarctic lakes, boiling hydrothermal vents, acidic pools. Life adapts. Life persists. Life survives. This realization transformed Europa from an interesting moon into one of the most promising locations in the search for extraterrestrial life. Imagine descending through the ice shell. Miles of darkness surround you. Above lies a frozen crust. Below stretches a black ocean illuminated only by whatever faint energy sources exist there. No sunlight penetrates these depths. No blue skies exist overhead. No familiar landscapes. And yet such an environment may not be as alien as it first appears. Deep within Earth's oceans, entire ecosystems thrive without sunlight. Around hydrothermal vents on the ocean floor, organisms survive using chemical energy rather than solar energy. Some scientists suspect similar environments may exist on Europa. If hydrothermal activity occurs at the bottom of its ocean, chemical reactions could provide energy for simple organisms, perhaps microbial life, perhaps something more complex. Nobody knows. That uncertainty is what makes Europa so fascinating. It occupies a unique position in modern science. We do not know whether life exists there. We do not know whether life ever existed there. But we know enough to keep looking, and the evidence keeps becoming more intriguing. Europa's surface contains strange regions known as chaos terrain. The name fits perfectly. Instead of smooth ice, these areas appear broken apart and reassembled like giant floating icebergs, frozen in place. Huge blocks seem to have shifted, rotated, and drifted before becoming locked together once again. Scientists believe these formations may result from interactions between the ocean below and the crust above. The moon's surface may literally be floating. In some places, Europa's icy shell could be surprisingly thin. Researchers have even suggested that pockets of liquid water may exist much closer to the surface than previously believed. These shallow reservoirs would be protected from Jupiter's deadly radiation by only a relatively thin layer of ice. If life exists, such locations could become prime targets for future exploration. And future exploration is coming. NASA's Europa Clipper mission was designed specifically to investigate this mysterious world in unprecedented detail. Rather than landing, the spacecraft will perform repeated close flybys, studying the moon's ice shell, ocean, chemistry, and potential habitability. Each pass will bring humanity a little closer to answering one of the oldest questions ever asked. Are we alone? Yet, as remarkable as Europa may be, it is only one member of Jupiter's extraordinary family, because another nearby moon offers something completely different. Not hidden oceans, not frozen landscapes, but fire. A world where volcanoes erupt constantly. A world so active that its entire surface is continually being rebuilt. A world that makes Earth seem geologically quiet by comparison. Its name is Io, and it may be the most volcanic place in the entire solar system. If Europa represents one of the coldest and most mysterious places in the solar system, then Io represents its complete opposite. Europa hides an ocean beneath miles of ice. Io hides an inferno beneath a thin rocky crust. The two moons orbit the same planet. They formed in the same neighborhood. They are roughly the same age, and yet they could hardly be more different. If you could stand on Europa, the world would appear frozen and silent. Endless plains of ice would stretch toward the horizon beneath a black sky dominated by Jupiter's enormous presence. But if you stood on Io, assuming you somehow survived the radiation, the experience would be almost overwhelming. The ground itself would feel alive. Volcanoes would erupt in the distance. Lava lakes would glow against the darkness. Mountains would collapse. Plumes of sulfur and ash would shoot hundreds of miles into space. The landscape would constantly change before your eyes. Io is not merely volcanic. It is the most volcanically active world ever discovered. Nothing else in the solar system even comes close. More than 400 volcanoes have been identified on its surface. At any given time, well over 100 may be actively erupting. Some launch material nearly 200 miles above the moon. To put that into perspective, commercial aircraft fly at roughly 7 miles above Earth. Some eruptions on Io throw material nearly 30 times higher. The moon appears less like a world and more like a gigantic pressure valve continuously releasing energy. The obvious question is why? How can a relatively small moon remain so active after billions of years? Most worlds cool over time. Earth itself has become less geologically active compared to its distant past. Mars largely shut down billions of years ago. Even our own moon became quiet long ago. Yet Io continues erupting as though it formed yesterday. The answer, once again, leads back to Jupiter. Just as Europa experiences tidal heating from Jupiter's gravity, Io experiences it on an even greater scale. The moon orbits extremely close to the giant planet. As it travels around Jupiter, gravitational forces constantly stretch and squeeze its interior. Imagine taking a rubber ball and compressing it repeatedly. The material inside warms. Now imagine doing that continuously for billions of years. The heat has nowhere to go. Io's interior remains molten because Jupiter never stops squeezing it. The moon's orbit becomes a gigantic gravitational torture device. Every orbit generates more heat. Every orbit fuels more volcanic activity. Every orbit ensures that Io remains one of the most extreme places in existence. Standing on its surface would be unlike anything humans have ever experienced. The sky would be black even during the day. Jupiter would dominate the heavens, appearing almost 40 times larger than our moon appears from Earth. It would look less like a celestial object and more like a second sky. Its colorful cloud bands would stretch across enormous portions of the horizon. The great red spot itself would be visible without a telescope. Meanwhile, beneath your feet, the ground would slowly rise and fall. This may sound impossible, yet Io experiences something similar. Earth's oceans rise and fall because of the moon's gravity. On Io, the crust itself rises and falls. The tidal bulges can exceed 300 feet in height. Imagine the entire landscape behaving like a slow-motion ocean. Mountains subtly lifting, valleys gently sinking, the ground itself breathing under the influence of gravity. No other rocky world experiences anything quite like it. The result is constant geological violence. Lava rivers snake across the landscape. Enormous volcanic plains cover vast regions. Sulfur compounds paint the surface in brilliant shades of yellow, orange, red, black, and white. From orbit, Io looks almost unreal, more like a work of abstract art than a moon. The colors come from volcanic materials constantly resurfacing the landscape. Unlike heavily cratered worlds that preserve ancient impacts, Io continuously erases its history. Every eruption lays down fresh material. Old features disappear. New ones emerge. The moon effectively rebuilds itself over and over again. Yet, despite all this activity, Io may not be the most fascinating moon in Jupiter's family, because farther out lies another giant, a moon so large that if it orbited the Sun directly, early astronomers might have classified it as a planet. Its name is Ganymede, and it holds several records that make it one of the most remarkable objects in the solar system. Ganymede is the largest moon known to science. It is even larger than Mercury. If size alone determined planetary status, Ganymede might have earned a very different title. Yet despite its enormous dimensions, the moon remains overshadowed by its parent planet. Perhaps that is fitting. Jupiter has a habit of stealing attention from everything around it. Still, Ganymede possesses secrets entirely its own. Beneath its icy exterior lies another enormous ocean. In fact, scientists believe the moon may contain more liquid water than Earth. The numbers become difficult to comprehend. The ocean beneath Ganymede's surface could extend 60 miles deep or more. Some estimates suggest it may contain 10 times as much water as all of Earth's oceans combined. Yet unlike Europa, Ganymede's ocean is likely trapped beneath an even thicker shell of ice. The deeper layers experience such extreme pressures that liquid water may transform back into exotic forms of ice despite the immense temperatures. The ocean itself could resemble a gigantic layered structure. Ice, water, ice again. Different forms stacked upon one another like pages in an enormous planetary book. And then there is another surprise. Ganymede possesses its own magnetic field. This makes it unique among moons. No other moon in the solar system has a magnetic field generated from within. Scientists believe this is possible because Ganymede still contains a liquid metallic core. Deep beneath the ice and ocean, molten material continues moving. That motion creates a miniature magnetic shield, a tiny version of the process occurring inside Earth. In some ways, Ganymede resembles a hybrid, part moon, part planet, part ocean world, part frozen relic from the earliest days of the solar system. And beyond Ganymede lies Callisto, ancient, silent, unchanged. If Io represents activity and Europa represents possibility, Callisto represents memory. Its surface has remained largely untouched for billions of years. Craters cover the landscape. Ancient scars remain preserved. Unlike Earth, where weather and geology constantly erase the past, Callisto remembers almost everything. Looking at Callisto is like looking backward through time. Some regions preserve events that occurred more than 4 billion years ago. The moon is effectively a museum of solar system history, frozen, silent, patiently waiting for future explorers. Together, these moons reveal something extraordinary. Jupiter is not simply a planet. It is the center of an entire system of worlds, ocean worlds, volcanic worlds, frozen worlds, ancient worlds, potentially habitable worlds, and all of them exist because of the giant planet they orbit. Yet, despite the wonders of its moons, Jupiter itself remains the greatest mystery. Because the deeper scientists investigate the giant planet, the more they begin asking an intriguing question. What exactly is Jupiter? Is it merely a planet? Or is it something much stranger? Because in many ways, Jupiter came surprisingly close to becoming something entirely different. A star. Jupiter is often called a failed star. At first, the phrase sounds dramatic, almost insulting, as though the largest planet in the solar system attempted something ambitious and somehow fell short. But the reality is much more fascinating than that. In truth, Jupiter occupies one of the strangest positions in nature. It exists right on the boundary between planets and stars, not close enough to become a star, not small enough to be an ordinary planet. Instead, it sits in a category almost entirely its own. When astronomers look at Jupiter, They are not simply looking at a giant world. They are looking at what happens when nature comes surprisingly close to creating a second sun. To understand why, we need to travel back more than 4.5 billion years. The solar system was a very different place then. There were no planets, no moons, no asteroid belt, no Earth, only an enormous cloud of gas and dust drifting through a quiet corner of the Milky Way. Eventually, gravity began pulling that cloud inward. The material collapsed. The center became hotter, denser, brighter. Over millions of years, a young star emerged, the Sun. Around that newborn star, leftover material continued orbiting in a giant disk. Tiny grains collided and stuck together. Pebbles became rocks. Rocks became mountains. Mountains became worlds. Among those growing worlds was Jupiter, and Jupiter grew quickly, very quickly. The young giant vacuumed up huge amounts of material before most other planets even finished forming. It became the dominant object in the developing solar system. Had it gathered enough additional mass, something extraordinary could have happened. Its core would have become hotter. Pressure would have increased. Hydrogen atoms would have started fusing together. A star would have been born. This is exactly how the Sun works. Deep within its core, hydrogen atoms collide under immense pressure and temperature. They fuse into helium. In the process, enormous amounts of energy are released. That energy eventually escapes as light and heat. Without it, Earth would be a frozen rock drifting through darkness. But Jupiter never reached that stage. It came close. Cosmically speaking, surprisingly close. Yet it remained far too small. To become a true star, Jupiter would need roughly 1,000 times its current mass. That sounds like a ridiculous number. And it is. If you stacked 1,000 Jupiters together, you would finally have something approaching the Sun. But there is another category between planets and stars, objects known as brown dwarfs. Brown dwarfs are sometimes called failed stars too. Unlike planets, they can briefly ignite limited fusion reactions. Unlike stars, they never become stable enough to shine for billions of years. They exist in a strange middle ground, a cosmic twilight zone. To transform Jupiter into a brown dwarf, you would need roughly 80 times its current mass. Still impossible under normal circumstances, but far closer than becoming a true star. If Jupiter somehow acquired that much material, the solar system would become unrecognizable. The giant planet would begin glowing, not like the Sun, not bright enough to create daytime on Earth, but bright enough to illuminate the night sky. Imagine stepping outside after sunset. Instead of darkness, a faint reddish object hangs in the heavens. A second sun, a dim one, a failed one, but a star nonetheless. The implications would be profound. Planetary temperatures would change. Orbits would slowly evolve. The appearance of the night sky would transform forever. Human mythology, culture, and history would likely have developed differently from the very beginning. Fortunately, Jupiter never became massive enough. Yet, it still shares some surprisingly star-like characteristics. For example, its composition. The Sun consists primarily of hydrogen and helium. So does Jupiter. In fact, if you stripped away the enormous differences in mass, the two objects would appear surprisingly similar. Both formed from the same primordial cloud. Both contain the same basic ingredients. One became a star. The other became a giant planet. The difference, largely, comes down to mass. Nature's simplest rule. Enough mass and a star ignites. Not enough mass and it remains a planet. Yet Jupiter continues doing things that seem almost star-like. Deep beneath its clouds, pressures become so extreme that hydrogen enters an exotic state known as metallic hydrogen. This is one of the strangest substances in the universe. Normally, hydrogen is a gas, the lightest element, simple, ordinary, but under immense pressure, hydrogen transforms. Its electrons begin moving freely. It starts conducting electricity like a metal. Scientists cannot easily reproduce these conditions on Earth. They exist naturally only within the deepest regions of giant planets. Entire oceans of metallic hydrogen may surround Jupiter's core, and these oceans are likely responsible for another remarkable feature: Jupiter's magnetic field. Earth possesses a powerful magnetic field. Jupiter's is vastly stronger, enormously stronger. If our eyes could somehow see magnetic fields, Jupiter's magnetosphere would appear gigantic in the sky. It is the largest planetary structure in the solar system. Its invisible influence stretches millions of miles into space. In fact, if Jupiter's magnetic field were visible from Earth, it would appear larger than the full moon despite being hundreds of millions of miles away. The giant planet effectively carries its own miniature space environment around with it. Particles become trapped within the field. Radiation belts form. Auroras glow near the poles. Entire moons experience its effects. Jupiter behaves less like a planet and more like a small system unto itself, a world with its own weather, its own oceans of metallic hydrogen, its own radiation environment, its own collection of worlds orbiting around it. No wonder astronomers often refer to Jupiter as a miniature solar system. Yet, perhaps the strangest thing about Jupiter is not what it is. It is what it could have been. Every object in the universe represents a path not taken. Earth could have become a barren wasteland. Mars could have remained warm and wet. Venus could have resembled a second Earth. And Jupiter could have become a star. A slightly different history. A slightly different amount of material. A few cosmic accidents occurring differently. And the entire solar system would look unfamiliar. Life on Earth may never have emerged. Or perhaps it would have evolved beneath two suns. The more scientists study planetary formation, the more they realize how fragile these outcomes truly are. Nothing about our solar system was guaranteed, and that realization leads to an even bigger question. If Jupiter came so close to becoming a star, how much influence has it had on everything else? Because there is growing evidence that Jupiter did far more than simply orbit the sun. It may have shaped the fate of every planet around it, including Earth itself. And perhaps, in a very real sense, Jupiter may be one of the reasons we are here at all. It is easy to think of Jupiter as distant. After all, the giant planet orbits nearly 500 million miles from the Sun. It hangs far beyond Earth, beyond Mars, beyond the asteroid belt, existing in a realm of cold sunlight and enormous empty spaces. From our perspective, Jupiter feels disconnected from everyday life. Its storms do not affect our weather. Its clouds do not darken our skies. Its moons do not influence our oceans. And yet, the deeper astronomers investigate the history of the solar system, the more they discover a surprising truth. Jupiter may have shaped Earth's destiny more than any other planet, perhaps more than any object besides the Sun itself. To understand why, imagine removing Jupiter completely, not shrinking it, not moving it, removing it entirely. The solar system would immediately become a very different place. Many of the stable gravitational relationships we take for granted would begin changing. Asteroids would follow new trajectories. Comets would travel along different paths. Entire regions of the solar system would slowly reorganize themselves. The giant planet's influence is so enormous that it acts almost like an invisible architect. Most of the time, we never notice, but its fingerprints are everywhere. One of the most obvious examples is the asteroid belt. Between Mars and Jupiter lies a vast region filled with rocky debris. Millions of asteroids orbit the Sun there, ranging from tiny fragments to objects hundreds of miles across. When astronomers first studied this region, they asked an obvious question. Why didn't all that material form a planet? The answer appears to be Jupiter. Its gravity constantly disturbs objects within the asteroid belt. Every time small bodies attempt to gather together and grow, Jupiter interferes. Tiny gravitational nudges accumulate over millions of years. Collisions become more violent. Orbits become unstable. Planet formation becomes increasingly difficult. The result is the asteroid belt we see today, a region that might have become a planet under different circumstances. Instead, it became a graveyard of unfinished possibilities. And this is only the beginning. Far beyond Neptune lies another mysterious region known as the Oort cloud. It surrounds the solar system like a gigantic shell extending trillions of miles into space. Hidden there are countless icy bodies left over from the formation of the planets. Most remain undisturbed for millions or even billions of years. Occasionally, however, something changes. A passing star, a gravitational interaction, a tiny disturbance. One of these frozen objects begins falling inward toward the Sun. It becomes a long-period comet. Some of these comets are enormous, and some have the potential to devastate planets. This is where Jupiter enters the story again. As incoming comets approach the inner solar system, many encounter the giant planet first. Sometimes Jupiter captures them. Sometimes it ejects them entirely. Sometimes it tears them apart. And sometimes it redirects them. The outcome depends on countless variables: a slight difference in speed, a slightly different angle, a slightly different approach. Everything changes. For decades, astronomers debated whether Jupiter acts as Earth's protector. The argument seems straightforward. Jupiter is huge. Its gravity is immense. Surely it must intercept dangerous objects before they reach us. And indeed, there is evidence supporting that idea. One of the most spectacular examples occurred in 1994. A comet known as Shoemaker-Levy 9 approached Jupiter. Years earlier, the giant planet's gravity had already begun tearing the comet apart. By the time it finally arrived, the object resembled a string of icy fragments rather than a single body. Then came the impacts. One after another, the fragments slammed into Jupiter's atmosphere. Gigantic fireballs erupted. Shockwaves spread through the clouds. Plumes rose thousands of miles above the planet. Some scars left behind were nearly the size of Earth itself. For the first time in history, humanity witnessed a major planetary collision unfold in real time. The event was both beautiful and terrifying, and it demonstrated something important. Jupiter absorbs impacts, lots of them. Researchers estimate that dozens of sizable objects collide with the giant planet every year. Many would otherwise continue traveling through the solar system. Some might eventually cross Earth's orbit. In that sense, Jupiter functions like a giant shield, a cosmic vacuum cleaner clearing debris from our neighborhood. Yet the story is not quite that simple, because Jupiter does something else. It redirects objects, and occasionally, those redirected objects head toward Earth. Imagine a giant traffic controller managing millions of vehicles. Most are sent safely away. A few are intercepted, but some are unintentionally redirected into dangerous situations. That is essentially what Jupiter does with comets. Its gravity is so powerful that it constantly reshapes trajectories. Some objects that would have missed Earth entirely can end up on collision courses after interacting with Jupiter. In other words, Jupiter may protect us and threaten us at the same time. This realization has forced scientists to rethink the giant planet's role. Perhaps Jupiter is neither guardian nor villain. Perhaps it is simply gravity on a massive scale, unconcerned with consequences, following only the laws of physics. Yet one possibility remains particularly fascinating. Some researchers believe a long-period comet influenced by Jupiter may have played a role in one of the most important events in Earth's history, the extinction of the dinosaurs. 66 million years ago, a giant object struck Earth near what is now the Yucatan Peninsula. The impact released unimaginable amounts of energy. Global ecosystems collapsed. The skies darkened. Food chains broke apart. And the age of dinosaurs came to an end. Without that extinction, mammals may never have risen to dominance. Without mammals, humans may never have appeared. The chain of events leading to our existence might have unfolded completely differently. And somewhere in that chain, Jupiter may have played a role. Perhaps indirectly, perhaps significantly. No one knows for certain, but the possibility is difficult to ignore. A giant planet orbiting hundreds of millions of miles away may have influenced events that eventually allowed intelligent life to emerge on Earth. The idea sounds almost absurd. Yet the universe often operates through connections that seem impossible until we understand them. A comet altered by Jupiter, an impact on Earth, an extinction event, the rise of mammals, the appearance of humanity, a chain stretching across millions of years. And if that sounds remarkable, it
1 minute
becomes
now
even
to
more
touchdown.
astonishing
Discovery's landing gear will be
when
launched down
scientists
and into
examine
place
the
at
earliest
300
days of the
feet in
solar
altitude.
system, because evidence suggests Jupiter may not simply have influenced Earth. It may have reshaped the entire
It's
solar
currently
system during its youth.
3,500 feet
In fact, there is
and
growing evidence that Jupiter once
traveling at a
traveled through
rate
the
of
solar system
370 miles
itself.
per hour.
And during that journey, it may have destroyed worlds before they ever had a chance
30
to form.
seconds until touchdown.
Today, the solar system feels stable. The planets move along predictable paths. Earth circles the sun once every year. Jupiter completes its journey roughly every 12 years. The moon rises and falls according to schedules so reliable that astronomers can predict
Main gear.
eclipses centuries into the future.
Landing gear now down and
Everything
launched.
appears orderly, permanent, almost inevitable. But that sense of stability is an illusion. The solar
Main
system
gear
we see
touchdown.
today is not
Pilot
the only
Jim
version
Dutton now
that could
deploying
have
the drag
existed.
chute.
It is simply the version that survived. 4.5 billion years ago,
Nose gear
our
touchdown.
cosmic neighborhood was a far more chaotic place. The young sun
That brings an
blazed
end
within
to
a
the
disk of gas and
STS-131
dust.
mission, the
Newly
131st
forming
Space Shuttle
planets
flight,
fought
and
for
the
space.
33rd to the International Space
Asteroids
Station.
collided constantly. Entire worlds were still taking shape. Nothing had settled yet.
Discovery left Florida
And
on
somewhere
April
within
5th
that
with
chaos, Jupiter was
7.6
growing.
tons of new science equipment and
Fast.
spare parts,
Very
including
fast.
equipment that should
So
improve the
fast, in
station's
fact,
capability for
that it
Earth
became the
observation work,
dominant planet
equipment that could
long
help
before the
astronauts avoid
others
muscle
had finished
atrophy,
forming.
and scientists better
Modern
understand muscle
computer
atrophy, and
simulations
equipment
suggest
that will help
that
keep the
Jupiter
station
did not
systems cooling
always orbit
properly.
where we find it today. Instead, the giant planet may have begun a remarkable journey through the early solar system, a journey that changed everything. The idea is known as the Grand Tack hypothesis. The name comes from sailing. When a sailboat changes direction, it forms a maneuver called a tack. According to this theory, Jupiter did something surprisingly similar. After forming, the giant planet began migrating inward toward the sun. At first, this sounds impossible. Planets seem fixed, permanent. Yet young planetary systems are surprisingly dynamic. The disk of gas surrounding the newborn sun exerted subtle forces on Jupiter. Over time, those forces caused the giant planet's orbit to shift. Slowly, relentlessly, the planet began moving inward. And as it moved, its immense gravity acted like a cosmic bulldozer. Imagine trying to build a city while a mountain slowly rolls through the construction site. That was essentially the situation facing the young solar system. Everywhere Jupiter traveled, smaller objects felt its influence. Some were scattered outward, others were thrown inward toward the sun. Many collided with one another. Some were destroyed entirely. The giant planet reshaped everything around it. And then something unexpected happened. Saturn grew large enough to become a significant player. The second giant planet began interacting gravitationally with Jupiter. Eventually, the two worlds became locked together in a delicate dance. Their combined gravitational influence altered Jupiter's migration. The giant planet stopped moving inward. Then it reversed direction. Slowly, Jupiter began moving outward again, back toward the region where we find it today. Like a ship turning around in the middle of an ocean. The consequences were enormous. Had Jupiter continued moving inward, the inner solar system might have been completely sterilized of planet-building material. Earth may never have formed. Mars may never have existed. The entire architecture of the solar system would look different. Perhaps there would only be a few giant worlds orbiting close to the Sun. Perhaps nothing resembling Earth would exist at all. Instead, Jupiter turned around. And because it turned around, worlds like Earth survived. The realization is difficult to overstate. One of the most important events in Earth's history may have occurred billions of years before Earth itself fully existed. A giant planet changed direction. And because of that decision, if we can call it that, the future remained open. Yet Jupiter's migration may have had another consequence. It may have destroyed entire worlds. Computer simulations frequently produce young planets that never survive. Some collide. Some fall into the sun. Some are ejected into interstellar space forever. Others are torn apart by gravitational interactions. When researchers reconstruct the earliest solar system, they often find evidence suggesting that additional planetary embryos once existed. These were not tiny asteroids. Some were comparable to Mars. Others may have been larger. Potential worlds, potential planets, potential Earths. Most are gone. No trace remains. Only gravity remembers. The possibility raises an unsettling thought. How many worlds existed briefly before disappearing? How many oceans never formed? How many atmospheres never emerged? How many planets were destroyed before life ever had a chance? We often think of the solar system as a collection of 8 planets, but perhaps it is more accurate to think of it as the survivors of a much larger family. A family shaped by collisions, migrations, and chance. Mercury itself may preserve evidence of this violence. The smallest planet in the solar system possesses an unusually large iron core. Scientists suspect that early Mercury may have been significantly larger than it is today. Then something happened, a colossal impact. The collision may have stripped away much of the planet's outer layers, leaving behind the dense metallic world we see today. If true, Mercury is not simply a planet. It is a survivor, a remnant, a world carrying scars from an age of cosmic violence. The same pattern appears elsewhere. Earth likely suffered a gigantic collision with a Mars-sized object known as Theia. The impact was so powerful that molten debris blasted into orbit around our planet. Over time, that material came together. The moon was born. Every time we look up at the night sky, we are seeing evidence of one of the most violent events in Earth's history. Without that collision, there may be no moon. Without the moon, Earth's tides would be different. Its climate stability might have changed. Perhaps life itself would have followed a different path. Again and again, destruction creates opportunity. Chaos creates order. Violence creates worlds. And through all of it, Jupiter remains present. watching, influencing, reshaping. The giant planet did not merely survive the formation of the solar system, it helped define it. Yet, what makes this realization even more extraordinary is that Jupiter's story is not unique. As astronomers began discovering planets around other stars, they found systems far stranger than our own, worlds larger than Jupiter orbiting impossibly close to their stars, planets moving along bizarre trajectories, entire solar systems that seemed to break every rule astronomers thought they understood. And those discoveries revealed something profound. The solar system is not the standard model. It may actually be the exception, which means Jupiter's journey is only one chapter in a much larger story unfolding across the galaxy. For centuries, astronomers assumed the solar system was normal. How could they not? It was the only planetary system humanity knew. The rocky planets occupied the inner region close to the sun. The giant planets lived farther away where temperatures were lower. Everything seemed logical. Everything appeared neatly organized. The closer you moved toward the sun, the warmer things became. The farther away you traveled, the colder everything got. Simple, elegant, reasonable. Then, in the 1990s, astronomers discovered something that shattered those assumptions almost overnight. A giant planet, larger than Jupiter, orbiting absurdly close to its star. The discovery was shocking. According to existing theories, such a world should not have existed. And yet there it was, a giant gas planet completing an orbit in only a few days. To understand how strange this was, imagine moving Jupiter inward until it orbited closer to the sun than Mercury. The giant planet would complete a year in mere days. Its atmosphere would be blasted by intense radiation. Temperatures would climb to thousands of degrees. By every conventional expectation, such a planet should never have formed. But nature had other ideas. Astronomers named these bizarre worlds hot Jupiters. And once they started looking for them, they found more, then hundreds more. Suddenly, the solar system no longer seemed typical. Instead, it looked unusual, perhaps even rare. Many hot Jupiters orbit so close to their stars that their atmospheres are literally being stripped away by stellar radiation. Some are so hot that clouds may consist of vaporized metals. Others experience winds moving at thousands of miles per hour. On certain worlds, temperatures exceed those found inside volcanic eruptions on Earth. Entire hemispheres glow from constant exposure to their stars. Imagine standing on a planet where one side permanently faces the sun, one hemisphere locked in eternal daylight, the other trapped in endless darkness. Between them lies a twilight zone where temperatures transition from inferno to deep freeze. These worlds sound like science fiction, yet astronomers observe them throughout the galaxy. The discovery of hot Jupiters forced scientists to rethink everything they thought they knew about planetary formation. The old picture suddenly seemed incomplete. If giant planets could exist so close to their stars, then planets must be capable of migrating enormous distances. And if planets migrate elsewhere, perhaps Jupiter migrated too. Suddenly, the grand tack hypothesis seemed far more plausible. The universe itself was providing evidence. Jupiter's journey was no longer a strange exception. It appeared to be part of a larger pattern. But hot Jupiters are only the beginning. As astronomers continued discovering exoplanets, they encountered worlds unlike anything found in our solar system. Some are called super-Earths. These planets are larger than Earth, but smaller than Neptune. Curiously, our solar system contains no examples. Yet elsewhere in the galaxy, they appear common. Some may be rocky. Others may possess deep global oceans. Some could have thick hydrogen atmospheres stretching thousands of miles into space. No one knows exactly what many of these worlds look like because they have no true equivalent nearby. Then there are mini Neptunes, gas dwarfs, ocean worlds, carbon planets, entire categories of planets that seem almost alien compared to the familiar worlds orbiting our sun. Every discovery makes the universe feel stranger and more diverse. For a long time, humanity viewed the solar system as a blueprint. Now we increasingly realize it may simply be one possibility among countless others, one arrangement, one outcome, one story, among trillions. Perhaps the most fascinating example involves planets where the weather itself becomes almost unimaginable. Earlier, we explored Jupiter's Great Red Spot, a storm larger than Earth. Yet elsewhere in the galaxy, astronomers have discovered worlds where it rains glass, not metaphorically, literally. Powerful winds carry vaporized minerals through the atmosphere. As temperatures change, tiny shards condense and fall from the sky. On some worlds, the glass rain may travel sideways due to extreme winds. Imagine standing in a storm where microscopic glass particles blast across the landscape at thousands of miles per hour. Other planets may experience iron rain, molten metal condensing high in the atmosphere before falling toward the surface. Still others may possess oceans of lava stretching across entire hemispheres. One particularly remarkable world is K2141b. It lies far beyond the solar system. At first glance, it sounds almost familiar. It has an atmosphere, clouds, weather, rain, a planetary water cycle, except none of those things involve water. The surface is so hot that rock vaporizes. Magma evaporates into the atmosphere. Winds transport the vapor toward the night side. There, it cools, condenses, and falls as rain, rock rain, an entire weather system built from stone. The planet essentially has a magma cycle instead of a water cycle, nature taking familiar ideas and rebuilding them in ways humans never expected. Every time astronomers think they have reached the limits of planetary diversity, the universe introduces something stranger, and these discoveries reveal something profound. The conditions that produced Earth are not guaranteed. The conditions that produced Jupiter are not guaranteed. Every planetary system is an experiment. Some create giant planets near their stars. Some create ocean worlds. Some create scorching lava planets. Some may create environments where life flourishes. Others may never become hospitable at all. The universe seems determined to explore every possibility, which raises perhaps the biggest question of all. If planets are so diverse, if planetary systems are so varied, and if worlds capable of supporting oceans appear relatively common, then where is everybody? Where is the life? This question becomes even more intriguing when we consider places closer to home. Europa may hide an ocean. Ganymede may contain more water than Earth. Mars may preserve ancient environments where life once existed. Even distant exoplanets hint at potentially habitable conditions. The ingredients appear widespread: liquid water, energy, complex chemistry. Yet so far, humanity has found no confirmed evidence of life beyond Earth. No signals, no organisms, no alien ecosystems, only possibilities. And perhaps that uncertainty is what makes the search so captivating, because every mission, every telescope, every new discovery brings us closer to an answer. Somewhere among the countless worlds scattered throughout the galaxy, nature may have repeated the experiment that produced life on Earth, or perhaps it produced something entirely different. And as we bring our journey through Jupiter and the wider cosmos toward its conclusion, we arrive at one final realization. The greatest mystery may not be hidden inside Jupiter. It may be hidden inside the universe itself. The deeper humanity looks into the universe, the stranger it becomes. That realization may be the single most important lesson in the history of astronomy. For thousands of years, our ancestors looked up at the night sky and believed they understood their place within it. The stars appeared fixed. The planets wandered across predictable paths. Earth seemed central, stable, permanent. Then the discoveries began. First came the realization that Earth was not the center of the cosmos. Then we learned that the Sun was merely one star among billions. Later, we discovered that our galaxy itself was only one among trillions. With every century, the universe grew larger, more complex, more mysterious. And today, after generations of scientific exploration, we find ourselves facing a humbling truth. We understand more about the cosmos than any civilization in history, yet we may still know only a tiny fraction of what is actually out there. Jupiter tells this story perfectly. What began as a bright, wandering object in the night sky eventually became a giant world larger than anything humans had imagined. Then it became a failed star. Then a planetary architect. Then the parent of hidden oceans, volcanic moons, and magnetic environments unlike anything on Earth. Every time scientists thought they understood Jupiter, new observations revealed deeper layers of mystery. The same pattern appears throughout astronomy. Answers rarely end the story. They simply reveal bigger questions waiting underneath. When the Voyager spacecraft first flew past Jupiter in 1979, the mission transformed our understanding of the giant planet overnight. Before Voyager, many scientists viewed Jupiter as little more than a large ball of gas. After Voyager, it became a dynamic system of storms, moons, radiation belts, and geological activity. Then Galileo arrived and revealed evidence for oceans beneath Europa. Then Juno arrived and discovered that Jupiter's atmosphere extends far deeper than expected. The planet's core turned out to be more complex than researchers predicted. The Great Red Spot proved stranger than models suggested. Again and again, nature refused to fit neatly into human expectations. And this pattern extends far beyond Jupiter. Every telescope pointed toward the universe uncovers phenomena that nobody predicted. Astronomers discover galaxies larger than expected, black holes more massive than anticipated, stars older than certain models allow, entire planetary systems that seem to violate assumptions about how planets should form. The universe behaves less like a solved puzzle and more like an endless frontier. Perhaps nowhere is this more obvious than in the search for life. For most of human history, the question seemed impossible to answer. Were we alone? No one knew. There was no evidence either way. Today, however, the situation has changed dramatically. Scientists have identified thousands of planets orbiting distant stars. Many exist within regions where liquid water could potentially survive. Some appear rocky, others may possess atmospheres. A few seem surprisingly Earth-like. Every year the list grows longer. Yet despite all these discoveries, we remain confronted by silence. No confirmed alien civilizations. No verified extraterrestrial ecosystems. No signals that can be definitively attributed to intelligent life. The universe appears filled with opportunities for life, yet so far Earth remains the only confirmed example. This contradiction is often called the Fermi paradox. The logic is deceptively simple. The universe is unimaginably old. The Milky Way alone contains hundreds of billions of stars. Many of those stars possess planets. A significant number likely formed billions of years before Earth even existed. If intelligent life is common, then some civilizations should be vastly older than humanity, millions of years older, perhaps billions. So where are they? Why do we not see evidence of galaxy-spanning civilizations? Why has nobody contacted us? Why does the universe seem so quiet? Scientists have proposed countless answers. Perhaps intelligent life is extraordinarily rare. Perhaps civilizations tend to destroy themselves. Perhaps interstellar travel is far more difficult than science fiction suggests. Perhaps advanced civilizations become invisible to younger societies. Or perhaps the universe is simply so vast that even thriving civilizations remain separated by unimaginable distances. No one knows. And that uncertainty remains one of the greatest intellectual mysteries humanity has ever encountered. Ironically, the more we learn about the universe, the more profound this mystery becomes. Every newly discovered planet adds another possibility. Every potentially habitable world deepens the question. Every hidden ocean beneath Europa's ice reminds us that life may emerge in environments once considered impossible. Perhaps somewhere beneath an icy crust, microorganisms drift through dark alien oceans. Perhaps distant exoplanets host ecosystems stranger than anything on Earth. Perhaps life has emerged thousands or millions of times across the galaxy. Or perhaps Earth truly is rare. Perhaps conscious observers are extraordinarily uncommon. Perhaps the fact that we exist at all is more remarkable than we currently appreciate. The truth is that we simply do not know, and there is something beautiful about that. Humanity often treats uncertainty as a weakness. We prefer answers. We prefer conclusions. We like the comfort of certainty. Yet uncertainty is what drives exploration. If every question were already answered, there would be no reason to build telescopes, no reason to launch spacecraft, no reason to study distant planets or search for hidden oceans beneath frozen moons. Curiosity exists because mystery exists. In many ways, Jupiter symbolizes that spirit of exploration perfectly. A world once seen as a simple point of light became an entire universe of discoveries. Its storms challenged our understanding of weather. Its moons transformed the search for life. Its gravity helped shape the solar system itself. And even now, after decades of study, Jupiter continues withholding secrets. Somewhere beneath those colorful clouds, enormous questions remain unanswered. Somewhere beneath Europa's ice, hidden oceans continue drifting through darkness. Somewhere beyond the solar system, countless worlds orbit distant stars, waiting for future generations to discover them. And somewhere in the vastness of the cosmos, answers to questions we have not even thought to ask may already exist. That may be the most humbling realization of all. The universe is not obligated to make sense to us. It does not organize itself according to human expectations. It does not simplify its mysteries for our convenience. Instead, it invites us to keep searching, to keep questioning, to keep exploring, because every generation stands at the edge of the known and looks outward into darkness. And every generation discovers that the darkness contains more wonder than anyone imagined. Thank you for joining us on this journey through Jupiter, its extraordinary moons, and the deeper mysteries of the cosmos. If you enjoyed this exploration, subscribe to Epic Space News for more long-form journeys into astronomy, space exploration, planetary science, and the biggest unanswered questions in the universe. And as you leave this video, take one final moment to remember that somewhere above you, beyond the clouds, beyond the moon, beyond the planets and stars, The universe continues unfolding its story, one mystery at a time.